All right, peeps. Welcome to Friday. We'll start with PowerPoint. Boom. Close that and go. All right. Now what we're going to look at is rational functions. And you say, what's a rational function? Well, we'll get into that in a second. And then we'll look at transformations from the reciprocal function, limits and asymptotes. And we're not going to worry about this too much, but we're going to analyze the graphs. Okay. What's a rational function? It's a fraction. Basically, a fraction is a rational function, but we're going to throw variables in it to make it more fun than just an ordinary little old fraction. Here's a rational function. What does it look like? Well, it looks like our 1 over x function. Remember our 1 over x function? It goes like that and like that. Okay. This one is very similar to it. It looks like this and this. Okay. So, what's going on here? Well, this tells us a lot right here. When we set the denominator equal to 0, that gives us a vertical asymptote. Vertical asymptote. So when we solve this, x equals -2. So you have a vertical asymptote right here at -2. Okay? Vertical asymptote at -2. Then, horizontal asymptote. What kind of horizontal asymptote do we got going on? Well, for this function, looks like our horizontal asymptote is 0. So what happens for a horizontal asymptote is when the numerator, let's call it n or m, and our denominator n, when n is greater than m, okay, this is the highest power of each, then our horizontal asymptote is y equals 0. Now, I said this wrong, didn't I? Yeah, I did. X to the n. X to the n. There we go. Now we got it. When the power in the denominator is higher than the power in the numerator, then y equals 0. If x to the m over x to the n, if n is equal to m, if they're the same size, then the horizontal asymptote is the coefficient of the highest power. We'll get to that. It'll be the coefficients of the highest power here. And then for the horizontal asymptote, x to the m over x to the n. If m is bigger than n, then there's no horizontal asymptote. Okay, no horizontal asymptote. So now, all right, vertical asymptote, x cannot equal -2. And then this next stuff is kind of interesting. What is this whole thing? Well, this thing is called a limit of a function. So what limits do is you get really, really close to something, but you don't ever quite touch it, such as you get really, really close to this asymptote, but you're never going to really touch it. So as we're approaching -2, this says as we're approaching -2, and the plus sign says from the right. So as we're approaching -2 from the right, where are we going? Well, we're going up forever. Where is up forever? Well, that's infinity. This says as we're approaching -2, as we're approaching this vertical asymptote from the left, because the negative sign means from the left, the negative sign up here. This negative sign has nothing to do with that. This negative sign says -2. This says from the left. As we approach it from the left, where are we going? Well, we're going down forever. Where's down forever? Negative infinity. Okay? All right. So the basic function 1 over the x, okay? The power in the denominator is higher than the power in the numerator, so we have a horizontal asymptote of 0. Y equals 0, that is. Our vertical asymptote is what makes the denominator 0. Well, that's x equals 0, makes the denominator 0. So here's our vertical asymptote, here's our horizontal asymptote, okay? So the domain is not all real numbers because 0 isn't on the function. You can't divide by 0. So this is why the domain is written like this, okay? And because we skip over 0, then a y value of 0 is not included either. So that's why it's written like that, okay? Continuity is discontinuous at x equals 0. So it's continuous for all other numbers except for x equals 0. And it's always decreasing as you're going from left to right, okay? As you're going from left to right, we're always going down here. So it's always decreasing, except for at 0 because there's a break there. It's symmetric with the origin, so it's an odd function. If you flip and then flip again, it's an odd function. Unbounded never has a min or a max. Okay, it doesn't turn around like that. No extrema because it goes forever. Horizontal asymptote of 0, vertical asymptote is 0. And as we go towards negative infinity, as this blue line goes left forever, it's getting closer and closer to 0. As the blue line goes right forever, that's what this means. As we're going to the right forever, it's getting closer and closer to 0. It'll never hit it, but it gets really, really close to it. So that's why it becomes a limit. Limit says, where are you getting really, really, really close to? Next. Okay, so if we have this function, how is it related to this function? Well, there's a 2 on top. What does a 2 on top do? Well, that makes it twice as tall. Okay, twice as tall. So instead of being, this one goes through the point 1, 1. So then this one would go through the point 1, 2. Whoop, come on. Wow, I'm struggling. This would go through the point 1, 2, but there's a negative here. So it goes through the point 1, negative 2. The negative, because this graph here looks like this. Because it's negative, it flips over the x-axis. So this one looks like this. Okay, take this one, flip it over the x-axis, and we get this one. And that's what this looks like. These are a little more complicated. This flips over because of that, and then moves to the left 3. Okay, and this one, there's multiple things that happen to that one. Okay, so 1 over x looks like that. We all know that. Okay, we're good there. It goes to the point 1, 1. Want to point that out. So if it's negative 2 over x, it's like negative 2 times 1 over x. So we're going to reflect it across the x-axis. Okay, stretch it by a scale factor of 2 because of the 2 here. Okay, vertical asymptote doesn't change, horizontal asymptote doesn't change. As we're going towards infinity and negative infinity, we're getting closer and closer to 0. Getting closer to 0 this way. Going this way, we're getting really close to a y value of 0. This says, as we approach 0 from the right, as we're approaching 0 from the right, where we go? Well, we go down towards negative infinity. As we approach 0 from the left, we go up towards infinity. Okay, as we're going this way with the graph getting close to 0, it's shooting up this way. All right, this one is the negative 2, and then we're just moving it. The negative 2 stretches it, and then we're moving it 3 to the left. So our vertical asymptote moves over negative 3. Okay, that should be fairly easy to get. Okay, we've transformed things before. So everything translates 3 to the left. We stretched it by 2. Horizontal asymptote doesn't change, but the vertical asymptote did. It's at negative 3. As we get closer to infinity or negative infinity, we're getting closer and closer to our horizontal asymptote of 0. As we go towards negative 3 from the right, go towards -3 from the right, we're going down forever. As we're going towards -3 from the left, we're going up forever. Okay. This one we'll skip. I think it's too complicated. But yeah, we're not going to talk about that one. Not going to talk about that one. Vertical asymptotes occur where the denominator equals 0. Okay, you cannot have 0 in the denominator, so that's why there's a vertical asymptote. X-intercepts will occur where the numerator is 0. Are the x-intercepts. And the y-intercept, when you plug 0 in for x, then you find the y-intercept. And all that can help us when we're graphing. So, this here, these two numbers tell us the vertical asymptote. X equals -1 is a vertical asymptote. X equals -5 is a vertical asymptote. These two numbers tell us the x-intercepts. You have an x-intercept of 3, and then this one would be -3. Okay? Now, if we multiplied all this out, x times x would be x squared, and x times x would be x squared. And when there's a 2 in front, this is like 2x squared in the end, if you distribute everything through. So, since these are the same power, you cancel it. You got a horizontal asymptote of 2 over 1. So, y equals 2 is a horizontal asymptote. Okay? That's how that works. And then our vertical asymptotes are that. There we are. We have a horizontal asymptote right here at 2. A vertical asymptote right here at -5. And another vertical asymptote right here at -1. Okay? So this shoots up really skinny. This goes here. This goes here. And you might say, well, how do I know where those are? Well, you know you've got an x-intercept at 3 and another x-intercept at -3. So you know it crosses there, and you know it doesn't cross here. So you can't have an asymptote here because it doesn't cross the x-axis. So you know this has to be up here. So if this is up here, and we don't have any squareds here, this is down here. And then since we did 2 of them, this sneaks. It wants to stay away from this one, so it's on this side. It wants to stay away from this one, so it goes over here. That's kind of how it works. For you, just graph them out of your graphing calculator. Take this, plug them into the graphing calculator, get a general sense of where everything is, but you still need to know vertical asymptote at -1, vertical asymptote at -5, x-intercept at 3, x-intercept at -3, and you got to know how to find the horizontal asymptote. Okay? There's another function. Got vertical asymptotes at 2, -3. And since this would be x squared down here and just a 1x up here, and there's no coefficients in front of any of them, well, it doesn't matter if there's coefficients or not. Your horizontal asymptote is going to be y equals 0 because the denominator power is higher than the numerator power. So graphing calculator will probably look like that. So you got that. Okay? So now, discard. What will your homework look like? Here we go. So 1 over x plus 4. If you have a graph, 1 over x plus 4 gives me a vertical asymptote at -4. Okay? So they can be all real numbers except for 4. And so horizontal asymptote at 0. And since it's not flipped around, it looks like this and it looks like this. All you have to do is graph it on the graphing calculator if you need to, but I can tell that just from looking at this. Okay? -4 here, vertical asymptote. And since there's no negatives involved, then we're here and here. Okay, as we're going towards -4 from the left, as we're going this way, we're going down. So that's -infinity. As we're going this way, we're going up. That's infinity. Now, -1 over x squared minus 4. When I see this, I factor this, x plus 2, x minus 2. So I know I have vertical asymptotes at 2 and negative 2. Okay? But then what's going on here? I really don't know. Honestly, I think it's a parabola. Yeah, this one's a little different. So we're not even going to worry about trying to figure out what it is by hand. We're just going to go slap this on the graphing calculator and go -1 divided by, make sure you use parentheses because it's only going to divide you by the x squared and then -4 from that. So make sure you use parentheses. X squared -4, boom, graph. Yep, I thought it was a parabola-ish thing. So, there's 2, there's -2. So it looks like this, it looks like this, it looks like this. Okay? So as we're going towards -2 from the left, we're going down towards negative infinity. Because as we move this way, we move down. As we go towards -2 from the right, as we're moving this way, what's happening? Well, as we're moving this way, we're moving up. So that's infinity. As we're moving towards 2 from the left, we're coming from the left, moving towards 2. Well, it's going up that direction. And as we're moving towards 2 from the right, my graph is down here going down, so it's negative infinity. Okay. What's happening here? Well, you see x minus 1. So if I go x minus 1 equals 0, x equals 1. So my vertical asymptote is 1 to the right compared to this one. So I'm shifted 1 unit to the right. Well, I already know this would be the right answer. Okay. Then vertical asymptote at x equals 1, horizontal asymptote. Since the denominator has a higher power than the numerator, oh, I did it again. Move down. Horizontal asymptote is y equals 0. So what does it look like? Well, since there's not a negative, it's going to look like this, and it's going to be 1 to the right. So we're here. Okay, and behavior. This stuff's pretty easy. As we go towards -4 from the left, go towards -4 from the left, what's happening? It's going up like this. As we're going towards infinity, what's going on? Well, as I go towards infinity this way, I'm getting closer to this asymptote. And it looks like, and we got to really zoom in on this one, peeps. Looks like our asymptote is right at 2 here. So we're going towards 2 because we're going, as we go further this way, it's getting closer to that horizontal asymptote, which is 2. As we're going towards -1 from the right, we're going up. We're going towards infinity. As we're going towards negative infinity, as we're going this way, we're getting closer to that horizontal asymptote. Looking at it, looks like we have a horizontal asymptote at -1. So that's the basics of how you do your assignment. And there's the answers. But yeah, that's the basics. Have a good weekend. I will be back on Monday.